so for 15, we're graphing exponential functions, and I'm going to rewrite this as 1 over 4 to the x. So thinking about our asymptote, no matter what I plug in for x, I will never get a value below 0. So my horizontal asymptote is at 0. For the y-intercept, that's when x is 0. So let's plug that in. Well, that's 1 over 1. So my y-intercept is 1. I have my asymptote, that is the line y equals 0. Now, because this is in the denominator, it's going to be a decay function looking like this. So the domain is all reals. The range is y is greater than 0. And the function is always decreasing. Another way we can think of it as being decay is because of this negative, it flips it over the y-axis. So instead of being a growth, it's flipped to be a decay. Now for B, my asymptote's moved up to 3. So that's at y equals 3. For my y-intercept, plug in 0. Well, 4 to the 0 is 1. We get 4. And it's a growth function because this is more than 1. So my domain is all reals, and my range is y is greater than 3, and it is always increasing. Now for C, my asymptote's at 0, and that's the line y equals 0. My y-intercept, when I plug in 0 for x, is 1. And because 2/3 is less than 1, it's going to be a decay function. So it is always decreasing. My domain is all reals, and my range is y is greater than 0. Okay, so for exponential word problems, we can use our calculators for these. 5,000 is our initial value, and it increases at a rate of 2.5% per year. So a formula for that, the population equals the initial population. We're increasing, so plus 2.5% by the year. So 1920, that's when t is 20, and 1950, that's when t is 50. So here we're going to use our calculator. 5,000 times 1.025 to the 20. And it says to the nearest whole number, so that is 8,193. Now for 50, instead of typing all this again, I'm going to do second enter and arrow over and change this to 50. And we get 17,185 people. I don't round up because that would happen in year 51, so we cut that off at the 5. Now for number 17, we're going to use our compound interest formula. So if we deposit $6,000 we get 4% compounded monthly, and we want 5 years, so T is 5. So again, we're going to use our calculator. I start on the inside of my parentheses and work my way out so that I make sure the calculator understands what order I want the operations to be done in. So to the nearest cent, $7,325.98. Okay, so for 18, because we're losing value, my formula for the car is the initial amount 1 minus that percent per year. So 1 minus 0.25 is 0.75. So this is our answer to B. So after 5 years, we're going to plug 5 in to T. We'll use our calculator. And we want to the nearest dollar. So that is $17,798. And that's our answer to part A. Okay, we're decreasing again. So the population started at 250,000. We're losing 5% per year. We would subtract 1 minus 0.05. We get 0.95 to the T. 10 years, we're going to plug in 10. Again, I'm going to use my calculator. And we want the nearest, we want the whole number. So that is 149,000. Oops, I forgot a 0. So multiply that by 10 since I forgot my 0. 149,684 people. And number 20. Compounding continuously, we use the formula principal times e to the rate times time. So $1,000, our interest rate is 7.4%, and we leave the money there for 6 years. So using our calculator, 1,000 times e to the 0.074 times 6. So that will give us $1,558.93.